we have an example problem here. A glass rod is charged to positive 8 nanocoulombs by rubbing. So question A, have electrons been removed from the rod or protons added? Question B, how many electrons have been removed or protons added? So glass rod, we end up with, it's telling us there's a net positive charge, Q, or capital Q, of 8 nanocoulombs. If this has a net positive charge, that means there's more protons than electrons. It doesn't mean there are not electrons. We're neglecting to draw all the little atoms in here that have both protons and electrons. We're only drawing the specific excess. So we are only drawing the excess charges. So going back to just my positive charges. All right. Electrons are the only fundamental charge that can move. Protons are in the nucleus of the atoms, and they are too tightly bound to the nucleus to be removed by rubbing. Okay, particle accelerators are required to break apart a nucleus of an atom. So the answer to A is electrons have been removed. This is the example of silk rubbed on glass. This silk would become negatively charged. So question B, we want to know how many. Oftentimes when we talk about how many of something, we use this capital N just to mean the number. We know the fundamental unit of charge. An electron and a proton both have a charge of 1.6 times 10 to the negative 19 coulombs. Now, that's just the magnitude. Protons are positive, electrons are negative. If we want to find the number of electrons that have been removed, we need to take the net charge and divide by this fundamental unit of charge. So this relationship will not tell us whether it was electrons or protons that moved. We must know that it's the electrons that move. Okay, that's something that we just need to understand. Here we know there's 8 nano is 10 to the negative 9. On the front cover of the test notes at the very bottom of the page, there's a little table of prefixes. We don't expect you to remember what all the different prefixes are. So nano is one of those. And when we divide by this, we're essentially doing a unit conversion. We're saying that there's 1.6 times 10 to the negative 19 coulombs per electron. So we're essentially saying 8 nanocoulombs of charge times E coulombs per electron. These coulombs cancel, and this is giving us the number of electrons. So these coulombs are canceling. And I'm getting 5 times 10 to the 10th. That is a lot of electrons. But again, that's not all of the electrons. It's just some of them. Atoms have lots of protons and electrons. Not atoms, sorry. The atoms have a few, but all objects are made up of many atoms.